So, are you trying to get your head around cloud computing for your AWS exam? I get it, but don't worry, you are in exactly the right place. In the next few minutes, we're going to break this down so simply, you'll be acing these questions. Okay, let's just dive right in. It's pretty wild when you look at the official AWS exam guide. A massive chunk of your score, yeah, almost a quarter of it, comes from just one single area. And that topic is cloud concepts. I mean, if you get this right, you are already well on your way to passing. So, what is the cloud, really? Let's make this incredibly simple. To really get it, we've got to compare how things used to be done, what we'll call the old way, with the new cloud way. And we're going to use a simple analogy that's going to stick in your head when you're sitting in that exam. Imagine this. You want to power your house. In the old days of computing, what we call on-premises, it was just like buying and running your own giant noisy power generator. You had to buy the fuel, you had to fix it when it broke down, and you had to take a wild guess at how big a generator you needed. It was just a ton of work, a huge expense, and a massive headache, right? Okay, so this slide really breaks it down perfectly. With your on-prem generator, you've got that huge upfront cost. In exam terms, and you gotta know this, that's called capital expenditure, or CapEx. But with the AWS Cloud, which is basically like plugging into the main power grid, man, it's a totally different ballgame. You just pay as you go. That's an operational expenditure, or OpEx. AWS manages all the complicated hardware, you just get power when you need it. Now listen, if you remember nothing else, remember this. That fundamental shift from CapEx to OpEx is a huge deal on the exam. So what does this all boil down to? It means the cloud lets you stop wasting money and time on all the boring stuff, like racking servers and managing data centers, and instead, you get to focus on building the cool applications and features that actually make your business stand out. That's the core value prop right there. All right, now that we've got the basic idea down, let's get into the good stuff, the specific benefits that AWS will absolutely test you on. I like to call these the 6 cloud superpowers. You need to know these cold. First up, agility. And this one is all about speed, right? Instead of waiting weeks or even months for new servers to show up, you can launch hundreds of them with just a few clicks in minutes. This lets your teams experiment and try new things like never before. And if an idea doesn't work out, no big deal. You just shut it down with no huge financial loss. Think about that for a second. It's incredibly fast and it's low risk. Next, elasticity. And hey, let's go right back to our power grid analogy. On a super hot day, everybody turns on their air conditioning and the grid just automatically provides more power. When it cools down, it provides less. Elasticity is exactly the same idea. It's the cloud's ability to automatically scale resources up and, just as importantly, this is key, scale them back down to perfectly match whatever demand is right now. You never ever overpay for capacity you aren't using. Okay, high availability. This just means your stuff is always on and ready for your users. AWS builds its entire global network with just incredible amounts of backup systems, multiple power supplies, network connections, even whole data centers, so that if one little thing fails, your application just keeps on chugging along without anyone even noticing. There's no single point of failure. And this one is just mind-blowing. With literally a few clicks of your mouse, you can deploy your application in different AWS regions, which are just physical locations all over the world. So this means if you have customers in Tokyo, you can serve them from a data center in Tokyo, giving them super fast, low latency performance. Just like that, you have an instant global presence. So you might be wondering, how is all of this so cheap? Well, here's how they do it. Economies of scale. Because a company like Amazon buys computer hardware by the hundreds of thousands, they get it at a massive discount that no single company could ever dream of getting. And here's the brilliant part. They pass those incredible savings directly on to you. You basically get to ride the wave of their enormous scale. And finally, we're back to the big one, the most fundamental concept of all, pay-as-you-go pricing. You're not locked into some long-term contract. You're not paying for a bunch of idle machines just sitting there. It's just like your electricity bill at home. You only pay for the exact amount of power, storage, and networking that you actually use for as long as you're using it. Simple as that. Okay, listen up. You get the superpowers now, right? But there is one specific question, a trap, that is designed to trip up almost everyone on the Cloud Practitioner exam. If you listen carefully for the next 60 seconds, you are not going to fall for it. The question's going to look something like this. They'll give you a scenario and try to confuse you between elasticity and scalability. I know they sound super similar, but for the AWS exam, they are critically different. Okay, here's the dead simple way to remember this forever. Think of scalability as adding more lanes to a highway. You're getting ready to handle more traffic over the long term. Now, elasticity, that's different. Think of it as having special highway lanes that automatically open and close based on how much traffic there is right now. It's designed to handle a changing load, both up and down in real time. And here it is, the absolute key takeaway, the thing you have to remember. Elasticity is about growing and shrinking. That ability to automatically scale back down and save money is what makes a system elastic. Scalability is just about handling more. The exam loves to test you on this specific difference, so please lock it in your brain and do not forget this one example. All right, let's do a super quick recap to lock all this in for good. If you're about to walk into that exam room, here are the 4 things you need to know, cold, about cloud concepts. Number 1, the cloud is just a utility. You're renting power like you rent electricity. Number 2, it's OpEx, not CapEx. You're paying a variable bill, not a huge fixed cost upfront. Number 3, remember those 6 superpowers? Agility, elasticity, high availability, global reach, economies of scale, and pay as you go. And number 4, the big trap. Elasticity shrinks. It scales up and down. That's the key. So look, you've completely nailed the why of the cloud. You get these core concepts better than most people who walk in to take this exam. But the next question is obvious, right? What are the actual tools? What are the specific services like EC2, S3, and RDS that you're going to be tested on? Well, that's exactly what we're going to tackle next.
Okay, if you're taking the AWS Cloud Practitioner exam, listen up. You absolutely have to know the difference between public, private, and hybrid clouds. I'm not kidding, this stuff is everywhere on the test, and getting it right is, well, it's critical for passing. So let's nail this down right now.
And hey, don't just take my word for it. Look at this. This is pulled directly from the official AWS exam guide. See that? Task Statement 3.1. It literally says you need to identify these different deployment models. AWS is basically handing you the answers to the test here, telling you exactly what to study.
So here's the deal. This is a core concept, and that means these are easy points for you. Get this right, and you're basically walking into that exam room with a few correct answers already in your pocket. We are not leaving those points on the table. No way. But okay, let's be real for a second. When you're in the exam and that timer is ticking down, it's super easy to get these terms mixed up, right? So how do we make sure you remember the difference under pressure? How do you lock this in so it's just automatic?
All right, I've got a super simple analogy that's going to make this whole thing click. I want you to think of it like choosing a place to live. That's it. Seriously, this one idea is the key to unlocking everything.
So first up, the public cloud. In our little analogy, the public cloud is like renting an apartment. Stick with me, you'll see how this works.
And this comparison, it just fits perfectly. Think about it. When you rent an apartment, you're sharing the building with a bunch of other people, right? That's just like the public cloud. You're sharing the big underlying infrastructure with other customers. You pay your rent every month, which is exactly like the pay-as-you-go model in the cloud. And what happens if the plumbing breaks? You don't fix it, you call the landlord. Same deal in the cloud. If a server goes down, the provider, like AWS, they're the ones who fix it. The main thing to remember is you don't own it and you don't maintain it. Okay, let's talk about the exam itself. When you see public cloud in a question, I want these keywords to pop into your head. First, high scalability and elasticity. That's like being able to get a bigger or smaller apartment almost instantly. Second, the cost model is pay as you go. The fancy term for this, and you need to know this for the test, is operational expenditure, OpEx. You're paying as you go, not buying the whole building. So no huge upfront costs, and you get global reach right away. Just burn this into your brain. Public cloud equals OpEx.
All right, so if a public cloud is like renting an apartment, what's next? Well, that brings us to the private cloud. And you guessed it, a private cloud is like owning your own house.
And the biggest difference here is all about one word, control. When you own your own house, you can do whatever you want, right? Paint the walls purple, knock down a wall, it's all yours. But, and this is a big but, you are also responsible for everything. You paid that huge upfront cost to buy the house, and when the roof leaks, that's on you. This is a perfect match for a private cloud, which usually means it's on premises, right there in your own data center.
So, for the exam, what are the triggers, what are the keywords, maximum control, and security? That's the big one. Because you own it, you control it. And then there's the cost. Remember that huge upfront investment to buy the house? That's called a CapEx, or capital expenditure. So if you see a question that mentions a big initial investment or the word CapEx, ding, 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 your brain should immediately go straight to private cloud.
Okay, so we've covered the apartment and the house. But what if you need a little bit of both? Well, that's where our third model comes in, the hybrid cloud. And the analogy, it just keeps working. Imagine you own your house. That's your private cloud. It's where you keep all your important, sensitive stuff safe. But what about all that other stuff? You know, the holiday decorations, the extra furniture you only use once a year. You're not going to build a whole new wing on your house for that, right? No. You rent a cheap, flexible public storage unit. And that storage unit, that's your public cloud. So you get the security and control of your house for the important stuff, and the flexibility and low cost of the storage unit for everything else. It's the best of both worlds.
Now for the exam, it's not enough to know what a hybrid cloud is. They're going to ask you how you connect the two pieces. How do you connect your house to the storage unit? You need to know two key AWS services here. First, there's AWS VPN. That's like a secure tunnel over the public internet. Then there's the big one, AWS Direct Connect. Think of this as a private, physical road you build directly from your data center to AWS. It's super fast and secure. You've got to remember those two names, VPN and Direct Connect.
Okay, you're doing great. You've got the core concepts down cold. But wait, before we wrap up, we need to talk about the #1 trap that AWS sets on the exam for this topic. I want to make sure you see it coming and don't fall for it. And here it is. The single biggest mistake people make. Confusing hybrid cloud with multi-cloud. They sound almost the same, but they are totally different things. And trust me, AWS loves to put this on the exam to try and trip you up. So let's make this crystal clear so there's zero confusion. Hybrid cloud is connecting your private stuff, your house, your on-premises data center, to a public cloud like AWS. Got it? Private to public. Multi-cloud, on the other hand, is when you're just using services from multiple different public clouds. Maybe you use some AWS and some Google Cloud, for example. There's no private house involved. Please, do not get those two mixed up. All right, let's do a super quick rapid-fire recap to lock it all in. Public cloud, that's your apartment. Pay-as-you-go, think OpEx. It's super scalable, but you don't have total control. Private cloud, that's owning your own house. It's a big upfront cost, think CapEx. You get maximum control, but you have to manage everything. And finally, hybrid cloud, that's owning your house and renting a storage unit. You get the best of both worlds, connecting your private stuff to the public cloud. Got it? Good. Now you are ready for any question they can throw at you on this. All right, let's get right into it. If you're studying for the AWS Cloud Practitioner exam, you absolutely positively cannot skip the cloud service models. I mean it. Getting this right is a huge piece of the puzzle, so let's lock it in right now. So why is this one topic so important? Well, just look at the exam breakdown. Understanding these models hits two of the heaviest domains, cloud tech and services at a whopping 34%, and security and compliance at 30%. You get this, and you are well on your way to passing.
So no fluff, we're going to break down everything you need to know, clear up all the confusion, and get you totally prepped to nail this on the exam, and we're going to do it in the next few minutes. Ready? Let's go. We're talking about the big three: infrastructure as a service, platform as a service, and software as a service. You can think of these as the fundamental language of the cloud. You got to speak it to pass.
Okay, before we get into the jargon, let's just simplify this. The single most important thing to get is that the only real difference between these models is the line dividing what you manage versus what AWS manages for you. That's it. It's a sliding scale of responsibility. Now, to make this idea stick in your brain, we are going to use the classic pizza as a service analogy. Yeah, it sounds a little silly, but trust me, it's pretty much the easiest and best way to remember this stuff for your exam. All right, follow me on this. Making pizza at home from scratch. That's your traditional on-premises data center. You do everything. Now, IaaS is like getting a take-and-baked pizza. The shop gives you the dough and sauce, but you're still in charge of toppings and actually baking it. PaaS, that's pizza delivery. The pizza shows up ready to go, you just have to worry about the table and drinks. And finally, SaaS is just dining out. You show up, you eat, and you leave. You manage absolutely nothing. See that progression? You're offloading more and more work at each step. Okay, so the pizza analogy makes sense, right? Now let's connect it directly to the official terms that you are definitely going to see on the exam. First up,
Infrastructure as a Service, or IaaS. This is your take and bake model. AWS gives you the raw infrastructure, the servers, the storage, the networking, but you're responsible for everything on top of it. That means the operating system, the patches, your applications. You get the most control, but you also have the most work to do.
Next, we've got Platform as a Service, or PaaS. This is your pizza delivery. With PaaS, AWS handles the hardware and the operating system. You don't ever have to think about patching servers. Your only job is to upload your application code and manage your data. You get to focus on your code, not the plumbing underneath. And finally, Software as a Service, or SaaS. This is dining out. It's a completely finished product that's ready to use. You're not managing code, you're not managing servers, you're not managing, well, anything. You just log in and use the software. This is the least control for sure, but it's also the most convenient.
Okay, theory is cool and all, but let's be real. The exam is going to ask you to connect these models to actual AWS services. So let's do that right now with the exact examples you're likely to see.
And boom, here it is. This slide is everything. For IaaS, the #1 example is always Amazon EC2. You manage the OS on up. For PaaS, think of a managed database like Amazon RDS. You handle the data, AWS handles the database engine and the OS. And for SaaS, think AWS Workspaces, a virtual desktop you just use. Seriously, take a screenshot of this. This is your key to getting these questions right.
And hey, don't just take my word for it. This is pulled straight from the official exam guide. It says you need to be skilled in describing how responsibilities can shift. That is exactly what we are talking about. They are literally telling you what's on the test. So, knowing that this is a key topic, AWS loves to set up little traps to see if you're paying attention to that shifting line of responsibility. Let's look at a classic question that trips people up all the time.
So, imagine this exam question. Who is responsible for security patching the guest operating system? In which of these models does that job fall on you, the customer? Just think about it for a second. In which model do you even have access to the OS?
And the answer is IaaS. In an IaaS service like EC2, you control the operating system, which means patching it is your job. But in a PaaS model, AWS manages that whole platform layer, so they handle the OS patching. This one distinction is a guaranteed point score on the exam if you can remember it.
Phew, all right, we've covered a lot, so let's boil it all down into a super fast recap you can use as a last-minute cheat sheet.
Here we go, rapid fire. IaaS. You get the infrastructure, like an EC2 instance. You manage the OS. PaaS. You get the platform, like a database with RDS. You manage your code and data. And SaaS. You get the software, like workspaces. You manage basically nothing. That's it. So, I'll leave you with this one final question to really cement it in your mind. Now that you get the models, which one gives you the absolute most control, and which one is all about convenience? It's all about that trade-off. Understand that, and you're thinking like a real cloud professional.
All right, welcome. We're going to do a quick explainer today, and we're totally focused on one thing, getting you to master a core concept so you can walk into that AWS Cloud Practitioner exam feeling confident and, walk out with a pass. Okay, let's just dive right in. Look, if you're cramming and only have time to really lock down a few concepts for the test, this has to be one of them. I'm serious. Understanding the AWS global infrastructure, it's not just important, it's absolutely fundamental.
And I'm not exaggerating here. I can pretty much guarantee you're going to see questions about regions and availability zones on your exam. Getting this right, it could literally be the difference between passing and failing. So yeah, let's make sure you nail these points.
So what are these things anyway? The easiest way to get it is to think about it from the ground up. We're going to start with the smallest piece, the most basic building block, and then kind of zoom out from there. Okay, first up, we've got the availability zone, or what you'll see called an AZ. Don't worry about all the official jargon. Just think of an AZ as a single, super reliable, totally isolated location. It's basically one, or maybe even a few, massive data centers, all built to handle failures. This is the bedrock, the foundation of everything. All right, now let's zoom out one step. A region, well, it's really just a physical area in the world, like North Virginia or Ireland or Tokyo. And it's made up of a bunch of those availability zones we just talked about. That's it. It's just a group of AZs all clustered together. And this is where it clicks into place. You can see the relationship right here. The region is kind of like the parent. For example,
US East 1, that's the code for the North Virginia region. Then the availability zones are like the children living inside that region, and they get names like US East 1A, US East 1B, and so on. And here's a key fact. A region will always have at least 2 AZs. Always. I love this analogy because it just makes so much sense. Think about it. A region is like a whole city, and each AZ is a separate pizza kitchen in that city. Now, what happens if you only have one kitchen and its oven breaks? Well, nobody gets pizza, right? But if you have multiple kitchens spread all over town and one oven breaks, it's no big deal. The other kitchens just keep making and delivering pizzas. They just pick up the slack. And that pizza story, it leads us straight to probably the most important keyword for your exam on this topic: high availability. That's the whole reason AWS built their infrastructure this way. It's all about making sure things keep running no matter what happens. So this naturally leads to a big exam question, right? Why? Why did AWS go through all this trouble to build things this way? What's the benefit of having all these separate, isolated facilities inside of one single geographic area? Okay, this slide right here, this is pure gold for your exam. Seriously, screenshot this. These are the keywords you have to connect with the infrastructure. So when the exam mentions things like high availability or fault tolerance, your brain needs to immediately scream, use multiple AZs. That's how your app survives if one data center goes down. Simple. But what about bigger things, like disaster recovery? Think a whole city getting hit by a hurricane. For that, you need multiple regions. Same for data sovereignty, which is just a fancy way of saying you have to keep your data inside a specific country's borders. And latency? To make things fast for your users, you just pick a region that's physically close to them. So remember, small problem, multi-AZ. Big problem or location-specific stuff, multi-region. And if there is just one number you burn into your brain for this whole topic, it's this one, 2. The magic number is 2. The entire concept of high availability on AWS, it all starts with the number 2. It's the absolute minimum. All right, now let's talk about the common exam trap, because this is where so many people get tripped up. AWS loves, and I mean loves, to test if you actually get this, and they have a favorite little trick they like to pull. So you're going to want to pay really close attention to this next part. Knowing this little detail will absolutely save you from making a simple mistake and throwing away easy points. This is what separates the people who just memorized a few terms from the people who actually understand how it all works. Okay, here's the trap. They'll give you a scenario and ask about high availability. The mistake is thinking one AZ is enough. It's not. Running your application in a single availability zone is the very definition of a single point of failure. If that one AZ has a problem, boom, your application is down. To pass, you have to know, and I mean really know, that true high availability requires you to spread your application across at least 2 availability zones. One is never, ever enough. All right, let's do a super fast recap to lock all this in. If you've been taking notes, this is the part you want to star, highlight, whatever. Review this right before you walk into that exam. It really boils down to 3 simple things. Step 1, an AZ is just a data center. That's the basic building block. Step 2, a region is just a group of these AZs in one geographic area. And step 3, the golden rule, for high availability, you need at least, say it with me, 2 availability zones. That's it. And that leads us to a final thought to chew on. You now know exactly how to design something to survive a single data center failure. You just use multiple AZs. But what's the next level? How would you take that same logic and build an application that could survive an entire city going offline? Think about that. An entire region wiped off the map. That's the next step up. And it all builds on the foundation you just mastered today. Good luck on your exam. You're going to do great.
All over your AWS Cloud Practitioner exam, it's this one, high availability. And I'm telling you, if you just get this one core idea that we're about to cover, you're going to nail those questions every single time. Okay, let's get into it.
So first things first, let's just frame the main idea here. Why this is even a thing we need to talk about.
I mean, think about it. All the apps you use every day, right? Netflix, your banking app, Google Drive. What really separates the ones you love and trust from the ones that just make you want to throw your phone? It's really just that simple. A great app, it just works. You don't even think about it. It doesn't die in the middle of a movie, and it for sure doesn't go down for maintenance right when you're trying to move money. It's just reliable.
And in the cloud world, that idea of being super reliable has a name: high availability. It's basically the promise that a system is built tough enough to handle problems and just keep on running without any interruption. It's the official technical way of saying always on.
Okay, I know. That definition sounds a little dry, kind of like a textbook. So let's make this concept completely crystal clear with a super simple story. I want you to picture your favorite little coffee shop. You walk in, and there's just one person behind the counter doing everything, our solo barista. They're taking the orders, grinding the coffee, making the drinks, handling the money, the whole shebang.
So, what do you think happens if that one person calls in sick? Well, the whole shop just grinds to a halt, right? The doors close, nobody gets their coffee, customers are unhappy, the business just stops. This is a classic textbook example of a single point failure.
Now, the solution to this problem is pretty obvious, isn't it? You hire a second person. You build in a little backup, a little redundancy.
Now, if one of the baristas is out for the day, the other one just steps up and keeps everything moving. The coffee keeps flowing. Customers might not even realize anything's different. The business is still running. And that, in a nutshell, is exactly what high availability is.
Okay, so great story. But you're here to pass an exam, not open a coffee shop. So how does this actually help you? Well, let's translate this analogy directly into the AWS terms you absolutely have to know.
And this is where it all clicks together. See how neatly this maps over? Our barista, the worker, that's like a server, or in AWS speak, an EC2 instance. And the entire coffee shop itself, the physical building, that's like one data center, which AWS calls an availability zone.
So let's lock this definition in because it is so important. An availability zone, or an AZ, isn't just a closet full of computers. You need to think of it as a completely separate, independent data center. It's its own building, with its own power, its own internet connection, its own cooling. This physical separation is the whole reason high availability even works.
And that brings us to what is probably the most important thing you need to remember for your exam. Seriously, if you forget everything else from this explainer, please remember this next part.
This right here is the golden rule. The entire AWS exam is basically built around this one idea. I want you to burn this phrase into your memory. High availability requires multiple availability zones. Not one, multiple.
So what does multiple mean? Well, for the Cloud Practitioner exam, the magic number you need to have in your head is 2. 2 is the absolute bare minimum you need to be considered highly available.
Now, just knowing that rule is going to help you dodge the single biggest mistake people make on these kinds of questions. Let's look at the trap they're going to set for you.
I promise you, you are going to see a question that looks something like this. They'll give you a scenario, a company has 10 servers for redundancy, all inside a single AZ. And then they'll ask you, is this setup highly available?
And the answer you are going to pick is a very clear, very confident no. Absolutely not. And why? Because even though it's pretty rare, an entire availability zone can fail. Think about it. A flood, a big power grid failure, a fire. If your whole application is sitting in that one building, it is going down. And this just hammers the whole point home. AZs are specifically designed not to share single points of failure. They are physically separate for a reason. So the key takeaway is that when you spread your stuff across 2 or more of them, you're protecting yourself from one of those data centers having a really bad day. One goes down, the other one keeps on chugging.
Okay, we've hit all the big ideas. Let's boil this all down into a super fast recap that you can just run through in your head right before you click start on your exam. Here we go. 3 simple steps. 1. High availability just means your app is always on. It's always working for your users. 2. The only way you can do this on AWS is by using a minimum of 2 availability zones. And 3. Why does it work? Because those AZs are totally independent. A disaster in one won't affect the other.
All right, if there's one topic you absolutely, positively cannot ignore for the AWS Cloud Practitioner exam, this is it. We're talking about Identity and Access Management, or IAM. Seriously, it shows up everywhere on the exam, and getting this down is a huge step towards passing. So let's just get right into it.
So why the big deal? Well, this number, 30%, that's how much the security and compliance part of the exam is worth. We're talking a massive chunk of your total score. And guess what's right at the heart of all AWS security? Yep, it's IAM. This number right here is basically AWS telling you, hey, you really need to know this stuff.
So let's talk about why IAM is so critical.
we're going to get into understanding who can do what in AWS. So what even is IAM? You know, the easiest way to think about it is like the ultimate security guard for your entire AWS account. It's the one service that decides who gets in, and even more importantly, what they're allowed to touch once they're inside. And look, getting this right isn't just some best practice. It's the absolute bedrock of a secure cloud setup.
Okay, let's break this down into the 3 core concepts: users, groups, and roles. Honestly, if you want to crush the exam questions on this topic, you have to lock in these 3 ideas. Just forget all the other noise for a minute and focus on these 3 things. If you can tell me the difference between a user, a group, and a role, you're already halfway there.
All right, first up, the IAM user. Now, what's a user? It's basically an identity for a person, like a developer on your team, or it could even be an application. But here's the key phrase you need to burn into your brain for the exam: long-term credentials. That means they get a permanent password or permanent access keys. They don't expire. It's a forever kind of identity.
Next up, the IAM group. So imagine you hire like 5 new developers all at once. Are you going to sit there and give permissions to each one by one? No way! That's slow, and you're bound to make a mistake. Instead, you use an IAM group. Think of it like a bucket you can just toss users into. You apply the permissions to the bucket, the group, and bam! Every single person in that group gets those permissions instantly. It's all about making your life easier.
And finally, we have the IAM role. Now, this one is super important for the exam because it's what AWS considers the most secure. If the keyword for a user was long-term, the keyword for a role is temporary. A role doesn't have its own password or keys. Instead, a user or even another AWS service assumes the role. When they do that, they get temporary credentials that expire. This makes roles the absolute gold standard for secure temporary access.
Okay, I get it. Users, groups, roles, it can all sound a little abstract. So let's make this super simple with an analogy. Let's pretend we're the security team for a big office building.
First, we have the employee. They work there every single day, so they get a permanent ID badge with their photo on it. It works Monday, it works Tuesday, it always works. That is your IAM user. It's a permanent identity with permanent credentials. Okay, so where does that employee work? Let's say the marketing department. Now, everyone in marketing needs to get to the same floors, right? And they all need to get into the same supply closet. Instead of programming every single badge one by one, the security team just creates a marketing access level. That's your IAM group. You just add an employee to that group, and they instantly get all the right access. Simple.
But what about a contractor? Someone who's just there for a few hours to fix the Wi-Fi? You would never give them a permanent employee badge, right? Of course not. You give them a temporary visitor pass. It only works on the 3rd floor, and it expires at 5 p.m. sharp. This is a perfect picture of an IAM role. It's limited, it's temporary, it's for a specific task, and because of all that, it's way more secure. All right, now that you've got that analogy locked in, let's shift gears and talk about the key principles you must know for the test. And listen, these aren't just, good ideas. These are literally the answers to exam questions.
Okay, first up, always follow the principle of least privilege. That just means you only give someone the absolute minimum permissions they need to do their job, and nothing more. Second, protect your root user account like it's gold. It has God mode in your account, so lock it down and never ever use it for your day-to-day stuff. Third, use multi-factor authentication or MFA on everything, especially that root account. The exam loves asking about MFA. Fourth, like we said, use groups to make managing permissions for lots of users way simpler. And last, but definitely not least, always choose roles for secure temporary access, especially for your applications.
All right, time to see if you've been paying attention. Let's talk about the common exam trap. AWS loves to throw these little curveballs at you just to see if you really get the most secure way of doing things. Let's look at a classic.
So here's the scenario. You have an application running on an EC2 instance. That's just a virtual server. And that application needs to get some data from an S3 bucket, which is your storage. The question is, what is the most secure way to give it permission? Just think about what we've been talking about. Permanent versus temporary.
Okay, here's where people get tripped up. The trap, the wrong answer, is to create an IAM user and then paste its permanent access keys right into the application's code. This is a massive security mistake, because if that code ever gets out, your secret keys are out there for the whole world to see. The right way, the secure way, the way AWS will always want you to answer, is to use an IAM role.
You just attach that role to the EC2 instance, and your app automatically gets temporary and rotating credentials. No secret keys in your code, ever.
Okay, we've covered a ton of ground, so let's lock it all in. Here's your 30-second recap, your IM cheat sheet for exam day.
It really boils down to this. A user, that's a person or an app with long-term permanent credentials. A group, that's just a collection of users to make applying permissions easy. And a role, that's a temporary identity for granting secure access. That's it. User equals permanent, role equals temporary. If you can just remember that one thing, you're going to be in great shape.
All right, if you're studying for the AWS Cloud Practitioner exam, you're going to want to listen up for the next few minutes. This is one of the biggest and honestly most confusing parts of the entire test, and we are going to make it super, super simple.
30%. Yeah, that's right. According to the official exam guide, that's how much of your final score is all about security and compliance. So getting these questions right isn't just a good idea. It's absolutely essential if you want to pass. Let's dive in and master the 4 key services that you're guaranteed to see on the exam.
Okay, so the easiest way to remember these services is to stop thinking of them as some random list of names. Instead, I want you to picture them as 2 distinct security teams. You've got your team on the outside and your team on the inside.
First up, let's talk about your perimeter guards. Think of these guys as being on the border. Their whole mission is to stop threats before they can even get close to your network. On this team, you have AWS Shield, which defends against those huge floods of traffic called DDoS attacks. And then you have AWS WAF, a firewall that actually looks inside the web requests to find and block malicious code.
Now, your second team is the internal detectives. These guys operate inside your AWS account. Their job is to find any threats that might have slipped past the perimeter or to find weak spots that already exist. This is where you've got Amazon GuardDuty, a super smart threat detector that's always looking for strange behavior in real time, and then you have Amazon Inspector, which scans for known vulnerabilities before an attack can even happen.
Okay, lists are fine and all, but an analogy is what really makes it stick. So let's imagine you're throwing a massive party at a mansion, and these 4 services are your security team. I'm telling you, this is the key to never mixing these up on the exam again.
So, AWS Shield, that's your heavy-duty security force with barricades at the edge of the property. They don't care about individual guests on a list. Their only job is to stop a giant, overwhelming mob, that's your DDoS attack, from even getting close to the house. It's all about protecting against pure volume.
AWS WAF, on the other hand, is your team of bouncers right at the front door. They're not stopping a mob, they're inspecting every single person trying to get in. They're checking IDs against the guest list and looking inside their bags for anything dangerous. Think of that dangerous stuff as malicious code, like a SQL injection attack.
So what about threats that are already inside? Well, that's Amazon GuardDuty. These are your undercover security guards just mingling with the guests at the party. They're constantly watching, using smart monitoring to spot anyone acting suspiciously, like someone trying to sneak into a locked room. They find weird behavior as it's happening.
And finally, we've got Amazon Inspector. Now, this isn't a guard at the party at all. This is the safety inspector you hired to walk through the entire mansion the day before the party even started. They're checking for unlocked back doors, faulty wiring, or any other potential weakness that a bad guy could use later. It's completely proactive. All right, that mansion party analogy should be locked in your brain now. So let's translate that into pure exam strategy. AWS uses very specific keywords in their questions that basically point you directly to the right answer. If you know these words, you honestly can't get it wrong.
So this is a big one. If you see the term DDoS, or Distributed Denial of Service, in an exam question, your brain should immediately just light up and scream AWS Shield. It is the service for DDoS protection. And don't forget, Shield Standard is free and automatically on for every single customer. For AWS WAF, the keywords are all about the type of attack. Be on the lookout for Web Application Firewall, or Layer 7, which is just the application level, and especially for specific attacks like SQL injection and cross-site scripting. Bottom line, if the question is about filtering the actual content of the traffic, it's WAF. GuardDuty questions will always use words that sound, well, intelligent. Things like intelligent threat detection, continuous monitoring, or machine learning. So, if the question is about detecting weird or malicious behavior happening inside your account, GuardDuty is your answer.
And for Inspector, the keywords are all about being proactive, about finding problems ahead of time. So think vulnerability assessment, or scanning your virtual servers, your EC2 instances, or finding software vulnerabilities. The key thing to remember is that Inspector finds the weaknesses before they can be attacked.
Okay, now for what I think is the most important part of this whole explainer. The single biggest mistake people make is confusing AWS Shield and AWS WAF. And AWS knows this. You better believe they write questions specifically designed to trap you.
So, let's look at a classic exam question. Your web application is being targeted with cross-site scripting attacks. Which service should you use to protect it? They're both perimeter security services, right? So, which one is it? Here's how you never fall for the trap. Shield cares about the quantity of traffic. Is a massive flood of data trying to overwhelm your server? That's a volume attack, a DDoS attack, and that's Shield's job. WAF, on the other hand, cares about the quality of the traffic. It looks inside the request to see if there's malicious code. So for that question about cross-site scripting, the answer is always WAF.
Okay, we've covered a ton of ground, but here is the entire thing condensed onto one single slide. Seriously, go ahead and screenshot this right now. It's the perfect cheat sheet for your final review right before you walk into that exam.
Let's run through it one last time, super fast. Shield is the heavy-duty perimeter security, and the keyword is DDoS. WAF is the bouncer at the front door. Keywords are SQL injection or SSS. GuardDuty is your undercover guard inside the party. Keyword is threat detection. And Inspector is the pre-party safety check. The keyword is vulnerability assessment. Master this table, and you will absolutely ace these questions on your exam.
All right, let's dive right in. If you're studying for the AWS Cloud Practitioner exam, we have to talk about encryption at rest versus encryption in transit. Seriously, this concept pops up constantly, and you've absolutely got to know this stuff if you want to pass.
So why is this so important? Well, take a look at this. This comes straight from the official exam guide. Security and compliance isn't just some tiny piece of the pie. It's a whopping 30% of your final score. I mean, think about that. Almost a third of the whole exam is just this one area. So yeah, understanding encryption isn't just a nice to have. You just can't skip it.
But here's the good news. Inside that huge security domain, you don't have to know every single thing. The exam guide is pretty cool about it and points out two main encryption options that you just have to get right. Out of everything, it really just comes down to these two.
And those two concepts are, you guessed it, data at rest and data in transit. Now look, if you're kind of new to IT, don't let these terms freak you out. I promise, we're going to break this down in a way that's super simple to remember.
And honestly, it's as simple as it sounds. Encryption at rest is all about protecting data that is just sitting there, not moving. We're talking about files saved on a hard drive, data chilling in an Amazon S3 bucket, stuff like that. It's stationary. Then you have encryption in transit, which is the opposite. It's all about protecting data while it's on the move, flying across the internet from your laptop to AWS or maybe from one AWS service to another.
Okay, to make sure this really sticks in your brain, especially when you're under pressure in the exam, let's use an analogy you won't forget. We're going to call it the safe and the armored truck.
So think of encryption at rest like this. Your data is locked up tight in a heavy-duty safe, right? It's not going anywhere. It's stationary, it's stored, and it's totally secure from anyone trying to get at it while it's just sitting there. Simple.
And on the flip side, there's encryption in transit. This is like moving your valuables from one place to another. You wouldn't just carry them, right? No, you'd put them in a secure, armored truck. The data is protected for its entire journey. If anyone tries to intercept it, they're not getting in.
All right, so you get the concepts now. That's the easy part. But how is AWS actually going to test you on this? Because they won't just ask for a definition. They're going to connect these ideas to specific services and keywords you have to recognize. This slide right here, this is basically your cheat sheet. When you see an exam question talking about protecting data at rest, like data stored in S3, your brain needs to instantly snap to AWS KMS, the key management service. And when the question talks about data in transit, like securing traffic from a user's web browser, you need to think SSL/TLS, which is handled by AWS Certificate Manager, or ACM. Seriously, burn these pairings into your memory. They are 3 points on the exam. Okay, you need to listen closely to this part. I'm going to show you a super common exam trap that gets people all the time, but it's not going to get you. Understanding this little trick will stop you from losing some really easy points.
So imagine this question pops up on your screen. It asks, how do you protect data while it is being uploaded to Amazon S3? Take a second. Really think about that word uploaded. Is that data at rest or is it in transit?
And that is the trap. The keyword, the only word that matters there, is uploaded.
While the data is moving from your computer to S3, it is in transit. It's only after that upload finishes and the file is saved in the S3 bucket that it finally becomes data at rest. The exam loves to test this, so always look for the action. Are they asking about the journey or the final destination?
Okay, we've covered a bunch, so let's lock it all in. Here comes a super fast recap with the key things you gotta remember for the exam.
All right, here we go. 30-second version. Data at rest? That's your safe. It's stored data. Think KMS. Data in transit? That's your armored truck. It's moving data. Think SSL/TLS. And when you're sitting in that exam, just ask yourself one simple thing. Is the data sitting still or is it moving? Get that right and you've got this.
All right, let's dive into one of the biggest and, honestly, most confusing topics on the AWS Cloud Practitioner exam: compliance and governance. I'm telling you, this stuff trips up so many people. But don't worry, today we're going to make this super simple. So right off the bat, look at this question. This is exactly what you'll see on the exam. AWS Config, CloudTrail, Artifact, Security Hub. I mean, they all sound kind of the same, right? It's so easy to guess wrong here. But stick with me, and by the end of this, you're going to look at a question like this and just know the answer instantly. And here's why this is so important. We're not just talking about a few questions here. The security and compliance domain makes up 30%. That's almost a third of your entire exam score. So you can't just kind of know this stuff. You have to know it to pass, no joke.
But here's the secret to getting it all straight. It really just boils down to one simple idea. Governance is all about setting the rules. It's you, in your AWS account, saying, this is how we're going to do things. Compliance, well, that's about proving you follow the rules. It's the paperwork, the reports, the evidence that shows you're actually doing what you said you would. That's it. Rules versus proof.
Let me give you an analogy that makes this click. Think about a brand new building. There's a fire code, right? A big book of rules that says you need sprinklers, you need fire exits, you need alarms. That fire code, that's your governance. Now, after the building is built, the fire marshal comes in, does an inspection, and gives you a certificate. That piece of paper, that report that says, yep, you followed the code, that's your compliance. See? One is the rule book, the other is the proof.
Okay, so now that we have that framework, rules versus proof, let's talk about the first piece, governance. We'll look at the tools AWS gives you to actually set and enforce all those rules inside your account.
First up, we have AWS Config. When you hear config, I want you to think of one word: configuration. This service is all about the what. What is the current state of my AWS resources? Is that S3 bucket open to the public? Does this database have encryption turned on? It's like a snapshot, constantly checking to see if your resources are configured the way your rules say they should be.
And then there's AWS CloudTrail. Now, if config is the what, CloudTrail is the who. It's your detective. It logs every single thing that happens in your account. Who launched that server? Who deleted that user? When exactly did they do it? And from what IP address? CloudTrail is the logbook that follows the trail of everything everyone does.
All right, everybody, lean in for this one. This is it. This is the big one. This is the most common trap on the exam when it comes to these services. And if you get this next part, I guarantee you will save yourself from losing easy points.
So imagine the exam asks you this: who deleted our S3 bucket last Tuesday? Now just stop and think for a second. Is this a question about the bucket's configuration, or is it about a person's action? It's CloudTrail, of course. You're asking who, so you're tracking an action. The trap is picking config. So here's the mnemonic I want you to burn into your brain. CloudTrail follows the trail of users. Config checks the configuration of resources. Just remember that, and you can't get it wrong.
Okay, awesome. We've totally nailed governance, which is all about setting the rules. So now let's flip over to the other side of the coin, compliance. Let's talk about the services you use to generate that proof that you're following the rules.
You know what? Just think of this slide as your exam cheat sheet. Seriously, if a question on the exam mentions needing to download AWS's SOC reports or their agreements, it is always AWS Artifact. If they talk about a centralized view for all your security alerts, you're looking at Security Hub. And if you see words like gathering evidence for an assessment or an audit, that's going to be Audit Manager. Just lock in these keywords.
Okay, let's do a super quick rapid-fire recap. Ready? Governance is the rules. Compliance is the proof. Config checks the what, the state of your resources. CloudTrail tracks the who, the actions of your users. And if you need an official report from AWS, like a SOC report, you go to Artifact. Got it?
All right, if you are serious about passing the AWS Cloud Practitioner exam, there are 3 concepts you've got to know cold: EC2, pricing, and auto-scaling. They're all over the test, and today we're going to make sure you nail every single one of them.
Look, this isn't just about grabbing a few points here and there. This stuff is foundational. It's how the exam tests if you really understand how the cloud works. So let's get these points locked down, starting right now.
Okay, first up, let's talk about the absolute cornerstone of AWS compute. Whenever you hear someone say they're running an application in the cloud, what are they really talking about? Well, 9 times out of 10, they're talking about EC2. It's where it all begins.
So what is EC2? It stands for Elastic Compute Cloud, and honestly, the simplest way to think about it is just a virtual server. It's a computer that lives in an AWS data center somewhere, and it's where you put your code, your websites, your applications, whatever you need to run. Seriously, it's the fundamental building block for almost everything you'll do in AWS.
The best way to get this is to think about renting a car, right? You don't own the car, you don't have to worry about oil changes or maintenance, but you can get one whenever you need it. And you get to choose exactly what you need. Need a small zippy car for a quick trip? You got it. Need a giant moving truck for a huge project? That's an option too. You use it for exactly as long as you need it, and then you just give it back. That's EC2. You're just renting the computing power you need.
So you've picked out your virtual car. Now, how are you going to pay for it? This is a huge deal, and trust me, the exam loves to ask questions about this. There are 3 main ways to pay, and knowing when to use each one is absolutely key, not just for the exam, but for saving a ton of money in the real world.
So you've basically got 3 main flavors here. First, there's on-demand. This is your standard pay-as-you-go. You use it, you pay for it. Super flexible, no strings attached. Then you have reserved. Think of this like leasing a car for 1 or 3 years. You're making a commitment, and in return, you get a massive discount. And finally, you've got spot. This is like bidding on spare, unused servers that AWS has just lying around. It is insanely cheap, but here's the catch. AWS can take it back anytime.
Now let's really dig into the biggest trade-off you'll face: on-demand versus reserved. On-demand is all about freedom. You can start and stop servers whenever you want, which is perfect when you're just starting out or have really spiky, unpredictable traffic. But you pay a premium for that flexibility. Reserved instances are the complete opposite. If you know for a fact that you need a server running 24/7 for the next year, you can reserve it and lock in a huge discount. We're talking up to 72% off. The only catch is, you're committed.
Okay, so what about reserved versus spot? They both offer big savings, but they are for totally different jobs. Reserved instances are your workhorse for anything critical. Your main database, your company website, things that absolutely cannot go down. You are guaranteed to have that capacity. Spot instances, on the other hand, offer the biggest discounts of all, but with 0 guarantees. AWS can literally pull the plug with just a 2-minute warning. So you'd only ever use these for jobs that can be interrupted, like processing a huge batch of data overnight. Never, ever for something critical.
Okay, so you have your servers, you've picked a payment plan, but what happens when your app suddenly goes viral? Or what about at 3 a.m. when no one's using your site? Are you just burning money on servers that are doing nothing? This is the exact problem that auto-scaling is built to solve. It's all about a concept called elasticity.
Whoa. Okay, exam alert. Seriously, pay close attention here because they love to trip people up with this. Elasticity is about automatically adding and removing servers to perfectly match demand. The rubber band analogy is perfect. It stretches out when you get busy and it shrinks back in when things get quiet. It works both ways. Scalability is a bit more general. It's just about your ability to handle growth, either by making your servers bigger or by adding more of them. But on the exam, when you see auto-scaling, the key word that should pop into your head is elasticity.
And the best part, setting this up is actually pretty straightforward. You just give AWS a few simple rules. First, you set a minimum number of servers you always want running, say 2, so you're always available. Then you set a maximum, like 10, so your bill doesn't explode. And finally, you define a trigger, a rule like, hey, AWS, if the average CPU usage across my servers goes above 70%, add another one. That's it. AWS handles the rest, perfectly scaling your fleet up and down for you.
Whew, okay, that was a lot. So let's boil it all down into a super simple cheat sheet. These are the things you want to have fresh in your mind right before you walk into that exam. Ready? Let's do a rapid-fire review. EC2, it's your virtual server. On demand, flexible but pricey. Good for unpredictable stuff. Reserved, You commit, you save big. Perfect for steady workloads. Spot? Dirt cheap, but it can be taken away. Only for things that can be interrupted. Auto-scaling gives you elasticity. And what's elasticity? Growing and shrinking. Get those straight and you're golden.
And now let's put it all to the test. It's time for a classic AWS exam trap question. This is exactly the kind of thing they use to separate the people who just memorize definitions from the people who actually understand how to use this stuff.
Okay, read this one carefully. Every single word matters. A critical database with predictable traffic, running 24/7 for 3 years. And the goal is maximum cost savings. So what's the answer? Think about it for a second.
So, if your brain immediately jumped to Spot because you saw maximum savings, gotcha. That's the trap. That phrase is bait. Yes, technically, Spot has the highest potential discount percentage, but it is absolutely 100% the wrong choice here.
Here's why. The real keywords, the ones that truly mattered, were critical database and predictable traffic. You would never, and I mean never, run a mission-critical database on a Spot instance that could just vanish with a 2-minute warning. It would be a disaster. For a workload this important, this predictable, and this long-running, reserved instances are the perfect fit. They give you the guarantee that your server will always be there, and they give you the best possible savings for a workload you can't afford to interrupt.
And that right there is maybe the most important lesson for the whole exam. It's not about memorizing which service is the cheapest or the fastest. It's about looking at the clues in the question and picking the right tool for that specific job. If you can master that way of thinking, you're not just going to pass, you're going to ace it.
Okay, let's talk about one of the most important services you're going to see on the AWS Cloud Practitioner exam. Seriously, it's S3, and it comes up all the time. Getting S3 right is, honestly, a make or break for passing. So if you want to really nail this down in just the next few minutes and feel totally confident for your exam, you are in exactly the right spot. We're going to make sure you ace these questions.
And hey, don't just take my word for it. Look at this. This is straight from the horse's mouth, the official AWS exam guide. It says right there in black and white that you need to be able to recognize the differences in S3 storage classes. I mean, come on, they are literally telling you what's going to be on the test. So yeah, let's make sure you know exactly what they're looking for. All right, so to really get a handle on S3, we're going to skip all the confusing tech speak. Forget that. Instead, we're going to use a really simple analogy that'll make it all just click. Think of it as a digital warehouse.
So at its core, S3 is what we call object storage. Now, that sounds way more complicated than it is. Don't let the name intimidate you. All it means is you're storing whole files. That's it. It's like when you upload a photo, a video, or a PDF to the cloud. You're not chopping it up into little bits. You're just putting the entire file, the whole object, up there.
So let's go back to that warehouse idea. Imagine an infinitely huge digital warehouse. You can shove anything in there. Your vacation photos, those massive 4K video files, all your company's documents, even complete backups of your servers. It's built to handle just a mind-boggling amount of data. And it's simple. You put stuff in, you take stuff out. That's really the big idea behind S3.
Okay, now we're getting to the part that is definitely on the exam, the real key stuff. So if S3 is this giant warehouse, ask yourself this: is every single thing you put in there equally important? Like, do you need it all at a moment's notice? Probably not, right?
Exactly. I mean, think about it. Are you going to need to access those tax documents from 10 years ago with the same urgency as the main banner image for your company's website? No way. And that single idea, that's the whole reason S3 has different storage classes. It's because AWS gets that not all data is created equal.
And this table here lays it all out perfectly. Here's the deal. The one thing you have to remember: the faster you need your data, the more it's going to cost. It's that simple. First up, you've got S3 Standard. Think of this as your hot storage. It's for stuff you need right now, like images on a busy website. It's super fast, instant access, but it's also the most expensive. Then we've got S3 Infrequent Access, or IA. This is for stuff you don't touch very often, like backups. Access is still instant, which is cool, but since you're not using it all the time, the storage cost is lower. And finally, we have S3 Glacier. This is like putting your files in a deep freezer. It's for long-term archiving, things you have to keep for legal reasons. It is incredibly cheap to store stuff here, but here's the catch. It can take minutes, sometimes even hours, to get your files back out.
Okay, so here's how this is going to look on the exam. They're going to give you a story, a scenario, and all you have to do is match that story to the right storage class. It's really just a matching game. So if the question says something about frequently used website images, you need speed, right? Boom, S3 standard. If it mentions monthly backups you rarely touch, your brain should go, okay, infrequent, that's S3 infrequent access. And if you see any of these keywords, archiving, legal compliance, or long-term, it's an automatic win. Your answer is S3 Glacier, every time.
All right, listen up, because this is one of the biggest traps on the exam. AWS loves to throw this curveball to see if you're paying attention. They want to know if you really understand the difference between S3, which is object storage, and this other thing called block storage.
Let's break it down. On one side, you have S3. We know this now, right? It's for whole files. The easiest way to think of it is like Dropbox or Google Drive. You put a whole file in, you get a whole file out. Simple. But on the other side, you have EBS, which stands for Elastic Block Store. This is a totally different beast. EBS acts like a virtual hard drive that you attach to a server in the cloud, an EC2 instance. It's basically the C drive for your cloud computer. This is where you'd actually install an operating system.
And here it is, the big trap, plain and simple. A question on the exam is going to ask you something like, you need to set up a new web server. Where do you install the operating system? And one of the options will be S3. That is the wrong answer. The only correct answer is EBS. You absolutely cannot install an operating system on S3. S3 holds the content for your website, the JPEGs, the videos, but EBS is the hard drive that runs the server. Get that straight, and you've just dodged a classic trick question.
Okay, deep breath. We've gone through a lot, but let's boil it all down to what you actually need to remember when you're sitting in that exam chair. This is your final, super quick cheat sheet to lock this all in.
Here are the 3 things to burn into your brain. Number 1, S3 is for objects, whole files. That's it. Number 2, match access to cost. If you need it fast, you pay more. If you can wait, you save a ton of money. And number 3, S3 is not a hard drive. You can't run an operating system on it. That's a job for EBS. If you can remember just those 3 things, you're in great shape for any S3 question.
Okay, let's talk about something you are definitely going to see on your AWS Cloud Practitioner exam: the difference between EBS, S3, and EFS. Seriously, these questions are everywhere, and getting them right can be the difference between passing and failing. But don't worry, in just the next few minutes, we're going to make sure you absolutely nail this. So check this out. This is a classic exam question right here. You've got high-performance database, EC2 instance, low-latency disk access. What are you thinking? What's the answer? If you're not 100% sure, stick with me. By the end of this, you'll be able to answer questions like this in your sleep.
And I'm not kidding. These core service questions, they are a huge chunk of your final score. They can absolutely make or break it. But the good news is we're going to break this down so simply it'll be impossible to get wrong. You ready? Let's get it right.
Okay, so here's the secret to getting this right. We're actually going to forget about AWS for a second. Yeah, you heard me. Forget all the tech jargon. Instead, we're going to talk about 3 types of storage you already know, using super simple analogies you use every single day. All right, first one up, block storage. The easiest way to think about this, it's your computer's C drive, the main hard drive. It's physically attached to your computer, right? That's what makes it super, super fast. It's where your operating system lives, where you install your programs. But here's the key thing, the absolute most important part. It belongs to one computer, just one. You can't just take your C drive and have your buddy's laptop use it at the same time. It's a one-to-one deal. Okay, next up is file storage. Now, for this one, I want you to picture the shared drive at your office or school. The S drive or the public folder where everybody dumps their files. The whole point is that many people on many different computers can all get in there and work on the same stuff at the same time. It's all about that shared access. That's the key word right there, shared. And our third one, object storage. This one's easy. Just think Google Drive, Dropbox, iCloud. You get the picture. It's like this bottomless pit on the internet where you can throw pretty much anything. Photos, videos, massive backup files, you name it. The big difference here is you don't attach it to your computer like a hard drive. No, you just access it over the internet, from anywhere. Your phone, your laptop, your friend's computer, anywhere. Okay, so let's recap. We've got the personal C drive, the shared office drive, and the infinite cloud drive. Simple, right? You got it. Awesome. Now let's connect these simple ideas back to the AWS services that you're going to be tested on. And here it is, the big reveal. It maps perfectly. That fast, personal C drive we talked about? In AWS, that's EBS, Elastic Block Store. That shared office drive for everyone? That's EFS, Elastic File System. And that massive, infinite cloud drive, you guessed it, that's S3, Simple Storage Service. Seriously, just burn this into your brain. Block is EBS, file is EFS, object is S3. Got it? Great. Okay, knowing the analogies is half the battle. But the exam loves to test you on the nitty-gritty details. So what we're going to do now is look at the ultimate cheat sheet. This is everything you need to know to pass these questions. Okay, this table right here, this is pure gold for your exam. Let's walk through it. We've got our analogies down, right? EBS is the C drive, EFS is the Office drive, S3 is Google Drive. That means the technical types are block, file, and object. Easy enough. But this next row, attached to, this is probably the single most important thing to remember. Look at this. EBS attaches to one EC2 instance in one availability zone. Just one. EFS, it attaches to many EC2 instances. And S3, well, it doesn't really attach at all, right? You just access it from the internet. This one difference explains everything about their use cases. EBS is for single server stuff that needs to be fast, like a database. EFS is for when you need to share files, like for a web server farm. And S3 is the go-to for backups, data lakes, hosting a simple website, pretty much everything else. If you can remember this table, you're in fantastic shape. Okay, you're armed with all the right info now, so let's talk about the #1 trap question AWS loves to throw at people. They do this all the time to see if you're really paying attention, and it's all about that idea of shared access. So take a look at this question. You see the keywords fleet of EC2 instances, multiple availability zones, and access the same data concurrently. Now, a lot of people see EC2 instances and their brain just screams EBS because, they work together. And that right there is the trap. That's exactly where they get you. Here's why that's wrong. Yeah, EBS attaches to EC2, but remember the rule? It only attaches to one instance. The question said a fleet of instances. That means many. And when many instances need to access the same data, that's our keyword, right? Shared access. The second you see many servers or shared access, your brain needs to go straight to EFS every single time. So here's the exam tip to remember, the golden rule. It's the rule of one versus many. If it's a one-to-one relationship, one server, one hard drive, that's EBS. If it's a many-to-one relationship, many servers, one shared file system, that is EFS. Just remember one versus many, and you will never, ever get this question wrong again.
Whew. Okay, that was a lot of info, but you're doing great. So let's do a super quick 30-second recap just to lock it all in your brain for exam day.
Ready? Here we go. EBS, think fast, single server C drive. That's your block storage. EFS, think shared office network drive for all your servers. That's your file storage. S3, think infinite internet bucket for anything and everything, accessible from anywhere. That's your object storage. That's it. It's really that simple. So let's circle all the way back to that question from the beginning. A company needs a high-performance database on a single EC2 instance with low latency access. The keywords, single EC2 instance. That's a one-to-one relationship that needs to be fast. And the answer is, of course, EBS. See? You've got this. You're ready for any storage question they throw at you.
All right, let's just dive right in. If you're studying for your AWS Cloud Practitioner exam, there is one topic you absolutely positively cannot afford to get wrong: the virtual private cloud, or, you know it, the VPC. Think of this as your definitive crash course to absolutely nail those questions.
And I am not exaggerating. This thing is literally all over the exam. You're practically guaranteed to see questions about its parts and especially its security. And why? Well, because the VPC is the fundamental bedrock of pretty much all AWS networking. If you can master this, you're building your knowledge on solid ground.
So just give me a few minutes of your time. We're going to break this down so simply that you'll actually be hoping these questions pop up on your test. Seriously, this is a huge opportunity to score some easy points.
Okay, so what in the world is a VPC? AWS has this really formal definition, but honestly, it can sound a little intimidating. So we're just going to slice right through that jargon.
So there you have it, the official textbook answer, a logically isolated section of the AWS cloud.
Okay, great. But what does that actually mean, in plain English?
This right here is the single most important idea to burn into your brain. A VPC is basically you taking a digital box cutter to the gigantic AWS cloud and carving out your own private, totally secure section. That's it. It's your own little corner, completely sealed off from everybody else.
So why does the exam care so much? Because this whole idea comes down to two key words that AWS loves to test you on: isolation and control. Inside your VPC, you're the boss. You control the IP addresses, you define the subnets, you set the network routes, you control everything. It is truly your own private space in the cloud.
Now, to make this concept stick in your head forever, let's use an analogy. This is, hands down, the easiest way to visualize all the different moving parts of a VPC, so you're going to want to pay close attention to this.
Just picture it for a second. A massive, sprawling, global city with infrastructure everywhere, connecting millions and millions of people and businesses. That's kind of like the AWS global infrastructure.
Now, within that giant city, you get to build your very own private, super secure office building. Nobody can get in unless you say so. That building is your VPC. It's totally logically isolated from all the other buildings in that city.
And what do you put inside this fancy building? Well, your employees, of course. And in our AWS world, your employees are your resources. Things like your EC2 instances, which are just virtual servers. They all live and work safely and securely inside your private building. Okay, let's add a couple more details. Think of subnets as the different floors in your building. Simple, right? You might put your public-facing team on the first floor, but you keep your super-secret finance department on the 10th floor, completely separate. And the internet gateway? Well, that's just the main lobby and the front door, controlling who and what comes and goes between your private building and the outside world, aka the internet.
All right, it's time for the most critical part, and I mean it. This is, without a doubt, the most heavily tested piece of the whole VPC puzzle. You've got your building, now how do you protect it?
Just think about a real office building for a second. Security isn't just one thing, is it? You have security at two different levels. First, you've got the main security guard for the entire floor, checking IDs for everyone who steps off the elevator. But then, you might have a dedicated bouncer standing right at the door of one specific high-security office. AWS uses this exact same two-layer approach.
And here they are. First up, you have the network ACL. Just think of this as the security guard for the entire floor, which is our subnet. It's that first line of defense. But then you have the security group. Now this is the personal bouncer standing right at the door of a specific server, our instance. It's a second, much more specific layer of protection.
Okay, I need your complete and undivided attention right here. I'm going to show you the number one trick question that AWS uses to test if you really understand VPC security. If you can remember this one thing, you are way ahead of the game.
This is it. This is the whole thing. They will try to confuse you on the difference between stateful and stateless rules. They sound kind of similar, but they work in completely different ways, and knowing that difference is absolutely crucial.
Here is the absolute key to nailing this on the exam. Security groups are stateful. Think of your friendly bouncer. If he lets you into the party, he remembers your face, and he'll automatically let you back out without asking. You only need a rule for traffic coming in. But network ACLs are stateless. This guard has zero memory. They check your ID on the way in, and you better believe they're going to check it again on your way out. You must create separate rules for both inbound and outbound traffic.
Okay, we have covered a lot, so let's lock it all in with a super fast recap. This is everything you need to remember for the exam, all boiled down to the absolute essentials.
Let's go. 1. A VPC is your own private, isolated network inside AWS. 2. Always remember the analogy. It's your secure office building. 3. Security groups are your stateful bouncers, guarding individual instances. The key word is they remember connections. And 4. Network ACLs are your stateless guards, protecting entire subnets or floors. They forget, so they check traffic in both directions. If you remember nothing else, please remember that.
And that's it. You now get what a VPC is, you know its key parts, you have the office building analogy, and most importantly, you know how to avoid that classic stateful versus stateless exam trap. You are ready. You've got this.
All right, if you're prepping for the AWS Cloud Practitioner exam, you've got to listen up. There is one concept you absolutely need to nail, and that's subnets. So let's dive right in. because knowing the difference between a public and private subnet, that's going to be a game changer for passing this thing. And I'm not joking around. This is pretty much guaranteed to show up on your exam. It's one of those core ideas that AWS just loves to test. So over the next few minutes, we're going to make this so simple, you literally can't get it wrong. So to really get what a subnet is, let's just forget all the technical stuff for a second. We're going to use a really simple analogy. Let's talk about building a house. Okay, so in the AWS world, your virtual private cloud, or VPC, that's your house. It's your own private, totally isolated piece of the AWS cloud. Think of it like your own plot of land that nobody else can touch. Now, you wouldn't build a house with just one giant open space, would you? Of course not. You have different rooms for different things. And that right there is exactly what subnets are. They're just the individual rooms inside your VPC house. And you use them to organize stuff like your servers and your databases. So, if our subnets are the rooms, this is where we get to the absolute heart of what you need to know for the exam. You see, not every room in a house has a door to the outside, right? And it works exactly the same way in your AWS house. Let's break this down. A public subnet, that's like your living room. It's got a front door that leads straight to the outside world, the internet. In AWS language, we call that front door an internet gateway. This is the perfect spot for things you want people to access, like your website's web servers. But then you've got your private subnet. Think of this like a secure vault or a safe inside your house. There is no direct door to the internet. This is where you lock away your most important stuff, like databases full of customer data. Now, your web server in the living room can still go and talk to the database in the safe, but nobody from the outside can just walk right into that safe. It's all about security and control. Okay, the house analogy is great for understanding the idea, but the exam isn't going to ask you about living rooms, right? It's going to use the official AWS terms. So let's pivot and look at the exact keywords you're going to see on the test. And look, this isn't just me guessing. This is pulled straight from the official AWS exam guide. See, it says you need to know about subnets. Those are our rooms, and gateways. That's our front door. It also talks about security, which we'll get to in just a second. So we are laser focused on what matters. So let's do a quick pop quiz. Imagine an exam question says you need to set up a web server for your customers. To make sure they can actually reach it from the internet, what is the one single thing its subnet absolutely must have? Think about our house. And the answer is an internet gateway. Yep. For a subnet to be public, it needs that front door. Without an internet gateway, a subnet is private by default. It really is that simple. If you need to reach the internet, you need that gateway. End of story. All right, now pay close attention, because this next part is where so many people get tripped up on the exam. AWS just loves to throw trick questions at you about the difference between having access and being secure. Let's make sure you don't fall for it. Here's the trap. Just because a room has a door to the outside doesn't mean that door is unlocked and anyone can just wander in. See the difference? Having a path to the internet is totally separate from what traffic is allowed on that path. And this table just nails the difference. The subnet, with its internet gateway, is all about the path. It just answers one question. Is there even a door to the outside? That's it. A security group, on the other hand, that's your firewall. That's the security guard standing at the door. It answers the question, okay, who is actually allowed to come through this door? You need both, a path and a guard. All right, we covered a lot. Let's lock it all in with a super fast recap of everything you need to remember for the exam. Number 1, your VPC is your own private house in the AWS cloud. Number 2, and inside that house, subnets are just the rooms you use to keep things organized. Number 3, and this is the big one, public subnets have a front door to the internet. That's the internet gateway. Private subnets are totally locked down from the outside. And finally, number 4, remember the trap. Subnets define the path, but security groups are the guards who control who can use that path. And that's really all there is to it. You now have the key to one of the most important networking concepts on the entire exam. Just think of it as your house, with different rooms and different rules, and you'll be able to handle any question they throw at you. So I guess the only question left is, what are you going to build in your house?
Are you getting stuck on those tricky VPC traffic questions on the AWS exam? Don't worry, you're not alone. But in the next few minutes, we are going to absolutely master route tables, so you can walk into that test and crush those questions with total confidence. Let's do this.
So you know how the official exam guide says you have to know about VPCs, subnets, and gateways. But here's the thing. Just knowing the parts isn't enough. The real exam questions, the tricky ones, they test whether you actually understand how a request from, say, an EC2 instance even knows where to go. What's the missing piece that connects it all?
Well, that secret is the route table. It's kind of the unsung hero of the VPC. It might not be the most famous AWS service, but it is one of the most powerful because it literally controls everything about where your traffic flows. Think of it as the air traffic controller for your entire cloud network.
Now, for the exam, you've got to have a solid definition locked in. A route table is just a set of rules. We call them routes. And these rules do one simple thing. They look at where traffic is trying to go, and they decide how it should get there. That's it. It's a traffic director. Plain and simple.
And look, this slide shows you just how simple it really is. A route table is basically just a list with two columns. You've got destination on the left, that's where traffic wants to go, and target on the right, that's where the route table sends it. So that first rule, 10.0.0.0/16, that just means any traffic going to another address inside our own VPC stays local. Easy. The second rule, 0.0.0.0/0, that's just a fancy way to say everything else, the rest of the internet. And where does it send it? To the IGW, the Internet Gateway.
So let's really picture this. You've got an EC2 instance sitting in your subnet, and it wants to send some data. The very instant that packet of data leaves the instance, the first place it stops for directions is the route table that's attached to its subnet.
And the route table acts like a bouncer to club. It stops that little data packet and says, whoa, hold on, let me see your ID. And in this world, the ID is simply the destination IP address. It's just checking, where are you trying to go?
Then, in a split second, the route table scans its list of rules. It finds the rule that matches the destination address, and boom, it forwards the packet to that rule's target. Now that target could be an internet gateway to get out to the web, could be a NAT gateway, doesn't matter. It's just the next hop on the journey.
Okay, if all that technical talk was a little fuzzy, don't even worry about it. I've got an analogy that's going to make this concept stick in your brain permanently for the exam. Just think of your entire VPC network as a city. The route table is its GPS.
This mapping makes it all make sense. The destination IP address, that's just the street address you're trying to get to. The target, like an internet gateway, that's just the next highway entrance the GPS tells you to take. And the route itself, well, that's the full set of driving directions. See? Super simple when you think about it that way.
All right, pay close attention here. This next part is pure exam gold. These are the key facts that pop up as multiple choice questions all the time. Think of this next slide as your personal cheat sheet for the test. Okay, let's do some rapid-fire facts. You're going to want to memorize these. First, every single subnet you create has to be associated with a route table, no exceptions. Second, if you don't bother to assign one yourself, AWS automatically connects it to the VPC's default main route table. Third, you can, and for most real-world setups, you will create your own custom route tables. Fourth, a single route table can be used by lots of different subnets. But fifth, and this is a big one, a subnet can only have one route table at a time. Just one.
Now let's talk about the #1 trap on the exam when it comes to route tables. This is where they love to trick people, but after this, you are not going to fall for it. It all comes down to what actually makes a subnet public versus private.
Okay, so picture an exam question like this. An EC2 instance can't reach the internet, but the question is nice enough to tell you that its security group is wide open. It allows all outbound traffic. So they're basically telling you it's not the firewall. They want to throw you off. So what is the most likely reason it's failing?
It's the route table. 9 times out of 10, in these scenarios on the exam, the problem is routing. Remember, the security group is like a bodyguard just for the instance, but the route table is the GPS for the entire subnet. And if the GPS doesn't have a route to the internet highway, you're not getting out of the neighborhood. So this brings us to the most critical, most important point. The only thing that makes a subnet public is its route table. It doesn't matter what you name it, it doesn't matter what you wish it was, a subnet becomes public if and only if its route table has a route that points internet-bound traffic, our old friend 0.0.0.0/0, to an internet gateway. If it doesn't have that specific route, it is a private subnet by definition. Period. End of story. All right, I know that was a lot, so let's lock it all in with a super fast recap. These are the key things you absolutely need to remember for the exam.
First things first, remember the analogy.
A route table is the GPS for your VPC. Its entire job is to be a traffic director, telling your data packets how to get to their destination.
Second, what's in a route table? It's just a simple list. It contains rules, and every rule just has two parts: a destination, which is where the traffic wants to go, and a target, which is the next stop to get it there.
And finally, the most important takeaway for your exam, the real game changer. What makes a subnet public? It is not the name. A subnet is public only if its route table has a route to an internet gateway. That single fact is the key to so many questions. You've got this.
All right, if you're gearing up for the AWS Cloud Practitioner exam, listen up. This is a big one. You absolutely must know the difference between running a database yourself on EC2 versus using RDS. I'm serious. Getting this right, it's like free points on the exam. So today, we're going to break down Amazon RDS so you'll never ever get it wrong again. Okay, let's get right into it. The #1 database mistake. This is where so many people trip up on the exam, confusing a managed service with the whole do-it-yourself thing. It's a classic, and you can bet the exam is going to hit you with it. So picture this. You're in the exam, and you see a question just like this one. Your app needs a relational database. What do? Do you roll up your sleeves and install it yourself on an EC2 instance, or do you use Amazon RDS? This isn't just a tech question, you know. It's really testing if you get the whole AWS way of thinking. Build it yourself or let AWS do the heavy lifting for you. And I'm not kidding, knowing the real difference here is a total game changer for your final score. It's not just about memorizing names, it's about understanding why you'd pick one over the other. Honestly, this can be the difference between passing and failing. So yeah, let's make sure you nail this. Okay, so to really get that question right, we got to know what we're talking about. So, what is Amazon RDS? Here's the official definition, but let's break it down. Amazon RDS, which stands for Relational Database Service, is a managed service. Its whole job is to make it super easy to set up, run, and grow a relational database in the cloud. We're talking about the big names here, right? Like MySQL, PostgreSQL, SQL Server, all those guys. With RDS, you can run them without ever having to think about the annoying stuff like patching, backups, or any of those other IT chores. Listen, if you remember only one single thing from this entire explanation, make it this word: managed. Seriously, burn it into your brain. Managed. This one little word is the key to, I'd say, like 90% of the RDS questions you're going to see. It's everything. And this chart right here, it shows you exactly what managed means. On the left, you've got the DIY approach, running a database on EC2. Look at all that stuff. You have to handle OS patching, install the database software, figure out high availability, backups, scaling. It's all on you. But now look to the right. With Amazon RDS, all of that just goes away. It shifts right over to AWS. They take care of all that, undifferentiated heavy lifting, so you can just focus on building your actual app. Okay, to make sure this idea is completely locked in, I've got a great analogy for you. I promise, after this, you will not forget it on exam day. Think of it like this. Using EC2 for your database is like deciding to cook a fancy meal at home. You have total control. Sure, you pick the ingredients, you use your own recipes, it's all you. But you also have to do everything. You got to buy the groceries, do the prep, cook the meal, and then you have to wash all the dishes. Now, RDS, that's like going out to a nice restaurant. You just show up, look at the menu, order what you want, and enjoy your meal. The restaurant handles everything else in the background. See the difference? One is all work, the other is all service. All right. Analogies are cool, but for the exam, you need cold, hard facts. So let's build your exam cheat sheet right now. This is the stuff you absolutely need to have memorized. Okay, here are your 4 golden rules for RDS. Number 1, it's a managed service. We've said it a bunch because it's that important. Number 2, it's for relational databases. Don't mix this up with NoSQL stuff like DynamoDB. That's a different beast entirely. 3, you still get to choose your engine, whether it's MySQL, PostgreSQL, whatever you like. And finally, number 4, the whole point is that AWS handles all that boring, undifferentiated heavy lifting for you. And now for the really good stuff. These are your exam keywords. Think of these as trigger phrases. When you're reading a question and you see words like reduce operational overhead or manage database solution, a little alarm should go off in your head. Ping! If the question is about a relational database and you see these phrases, the answer is pretty much always going to be RDS. Okay, pay close attention now. This is probably the most important part of this whole thing. We're going to talk about the classic exam trap.
the one AWS loves to use to catch people who weren't paying attention. So you'll get a question that sounds something like this. It'll ask for a database solution, but it'll have these little keywords tucked in there: full control or root access to the underlying operating system. Now, is RDS the right answer? No, absolutely not. This is the trap right here. Don't fall for it. I'll say it again. If you see root access or full control over the OS, RDS is the wrong answer every single time. And here's why. It all comes back to that magic word, managed. Because RDS is a managed service, AWS is the one managing the operating system. That means you don't get to log in. You don't get root access. You're trading that super low-level control for the convenience of having AWS manage everything for you. So if a question demands that control, you gotta go with the DIY option, which is a database on EC2.
All right, let's wrap this up and put a bow on it. I'm going to give you a super simple 30-second decision tree that you can literally run through in your head during the exam. Here we go. Just ask yourself 2 simple questions. First, do I need a relational database like MySQL or something similar? Second, do I want to avoid all the headaches of managing the operating system, patching, and backups? If you answer yes to both of those questions, boom, the answer is RDS. That's it. It's really that simple. And there you have it. That's the whole thing. You've got the simple explanation, you've got the restaurant analogy, you've got your exam keywords, and you know the #1 trap to avoid. You are totally ready to spot the difference on your exam. Now go nail those questions. All right, you're studying for your AWS Cloud Practitioner exam, and you need to know DynamoDB. Well, you came to the right place. In just the next few minutes, I'm going to give you everything you need to know to absolutely crush those questions. Let's do this. So, are the database questions on the exam making you a little nervous? Yeah, I totally get it. They can be pretty tricky. But honestly, don't sweat it. We're going to make this super simple, super fast, and give you the exact info you need to just knock those questions out of the park. Okay, first things first. Let's get right to the basics. We're going to skip all the super technical stuff. I mean, we're not trying to build a database from scratch here, right? We just want to pass this exam. So let's talk about what you absolutely have to know. Okay, listen up, because this is super important. There are 2 key phrases on this slide that you have to burn into your brain for this exam. When you see fully managed and NoSQL, I want you to immediately think DynamoDB. It should be an automatic connection. So fully managed is pretty easy, right? It just means AWS takes care of all the annoying back-end stuff for you, the patching, the scaling, all of it. But NoSQL, that's the one that gets people. So let's break that down right now. All right, so to make this NoSQL thing really stick, we're going to use a super simple everyday analogy. Let's just forget about all the tech stuff for a second. This is going to help you remember it, when you're sitting in the exam and the pressure's on. So check this out. On one side, we've got a relational database, like RDS. The best way to think about this is like a really neat spreadsheet. Every single row has to have the exact same columns. Name, email, phone number. It's very strict, very rigid. But then on the other hand, you have a NoSQL database. And this is our DynamoDB. Think of this one more like a big, messy filing cabinet. You can just throw whatever you want in there. One file can have a name and an email. The next one, maybe it's a username, a high score, a favorite video game character, who knows? It's totally flexible. You don't have to define everything in advance. And that, right there, is the biggest difference you need to remember. All right, you might want to screenshot this next one, or at least take a good mental picture. This is basically your exam cheat sheet for DynamoDB. These are the key facts that the exam questions are going to be based on. Okay, let's lock these in. Number 1, it's NoSQL. Remember our filing cabinet? Flexible. Number 2, it's fully managed. That means AWS is doing all the hard work for you. 3, it's fast and flexible. It's built for speed. And 4, it can scale to any size. Seriously, from a tiny little app to something absolutely massive. If you see these words in an exam question, it's like a giant flashing sign pointing right at DynamoDB. Okay, so knowing the facts is great, but that's only half of it. See, the AWS exam loves to ask scenario questions to see if you really get it. So now, let's talk about the #1 trap that people fall into, so that you don't. And here it is, the biggest trap. It's not some obscure technical detail. It's all about knowing when to use DynamoDB and when not to. This is the core of it, really. This is what the exam is testing.
So let's make it super clear. If you get a question about, say, a mobile game with player profiles or an online store where products have all sorts of different details, that screams flexible. You don't know the data structure up front. That's a job for DynamoDB. But if the question is about something like a bank ledger or a company's inventory system, where everything has to be super structured and consistent, like our spreadsheet analogy, well, that's when you'd choose a relational database like RDS or Aurora. Getting this difference is how you're going to nail these questions. It's all about the use case.
Okay, we have flown through a lot of info really quickly. So let's say your exam is tomorrow and your brain is just crammed. What is the one single most important thing you need to remember about DynamoDB? This, right here. This is the whole ballgame. If you remember nothing else, remember this. DynamoDB equals NoSQL. That's it. See a question that talks about a managed, scalable, non-relational database? The answer is DynamoDB. See a scenario that needs a flexible, unstructured data model? The answer is DynamoDB. Just connecting those two words in your head is going to get you through probably 90% of the questions on this topic. It really is that simple.
All right, let's get right into it. You're prepping for the AWS Cloud Practitioner exam, right? And you just know those pricing questions are going to pop up and try to trip you. Well, don't sweat it. In the next few minutes, we're going to totally demystify this stuff so you can walk in there and absolutely crush them.
So what's the deal? What's the #1 mistake people make? Honestly, it's that they get lost in the weeds. They make it way, way more complicated than it needs to be. But trust me, we're not going to let that happen to you. Not today.
All right, first up, the core pricing principles. And seriously, it's way simpler than you think, because here's the secret. The whole thing is built on one simple idea.
This, right here, this is the golden rule. If you walk away with just one thing, let it be this. You only pay for what you use. That's it. No giant, scary upfront costs for servers you might need. Nope. You just pay for the specific things you're actually using right when you're using them. That's the entire game.
So what does pay for what you use really mean when you're staring at an exam question? Well, it boils down to 3 main things they'll test you on. First, compute. Think of this as the brain power, the EC2 instances that are actually running your code. Second, storage. Pretty straightforward, right? This is the space you're renting for your data, like in S3. And third, and you're going to want to tattoo this one on your brain, data transfer out. We'll circle back to why that out is so important in a bit.
Okay, let's make this stick. We're going to talk about your AWS utility bill. The best way to think about this stuff is with a real-world analogy you already know inside and out.
Yeah, think about it for a second. How is your AWS bill like your phone plan? Sounds kind of weird, but this is the perfect way to understand the different pricing models you absolutely have to know for the exam. Let's break it down.
First up, on-demand pricing. This is just like your classic pay-as-you-go phone plan. No contract, no commitment. You just pay for the minutes and data you use. In the AWS world, this is perfect for when you have no idea how much power you'll need. Maybe you're testing a new app, or you have really spiky, unpredictable traffic. It gives you total flexibility, but you pay a little more for it.
Okay, but what happens when you know you're going to be using that phone every single day for the next year? You don't do pay-as-you-go, right? No way. You sign a contract to get a much better monthly rate, and that is exactly what reserved instances and savings plans are. You're basically telling AWS, hey, I promise I'm going to be using this stuff for 1 or even 3 years, and for that commitment, they give you a huge, huge discount. It's the classic trade-off. You give up some flexibility, you get big savings. All right, fun with analogies is over. Let's get down to brass tacks. These are the absolute must-knows for the exam. I can pretty much guarantee you're going to see these terms.
Okay, so when it comes to paying for compute, you've got 3 main choices. The exam loves to ask you to compare these. We've talked about on-demand for flexibility and reserved for commitment. But then there's the wild card, spot instances. This is where things get really interesting. You're basically bidding on Amazon's spare, unused computing power. The catch? They can take it back with just a little bit of notice. The reward? You can get savings up to like 90%. It's insane. So the whole game for the exam is knowing which one to pick in a given scenario. This table is your cheat sheet. Got a workload that's all over the place? Go on demand. Got a database that's running 24/7? Lock in those savings with reserved. Got a huge batch processing job that can be stopped and started without causing a disaster? Oh yeah, you're using Spot for those crazy deep discounts. It's all about matching the workload to the pricing model. Now, paying for stuff is one thing, but the exam also wants to know how you keep track of your spending. And for that, you need to know these 3 tools. Think of Cost Explorer as your accountant.
It shows you where your money went and where it's probably going. AWS Budgets is like a parent setting an allowance. It screams at you when you're about to spend too much. And Trusted Advisor? That's your savvy consultant popping in to say, hey, did you know you could save a bunch of money by doing this? You gotta know what each one does.
Okay, lean in for this one. Let's talk about a super common cost trap. This is one of those questions that seems way too easy, and that's exactly how they get you. But not you. You're going to see it coming a mile away.
Remember that little detail about data transfer out? Well, here's the trap. The exam loves to test this. You just have to burn this into your memory. Getting data into AWS is, for the most part, completely free. They want your data. But taking your data out of AWS and sending it over the internet, oh, that's going to cost you. So just repeat after me. In is free, out costs money. In is free, out costs money. Got it? Good.
All right, we've covered a ton of ground, but that was the really important stuff. Let's do a quick fire recap right now to make sure this is all locked in for exam day. Here we go. The absolute essentials. Number 1, you pay for compute, you pay for storage, and you pay for data transfer out. Number 2, on-demand equals flexibility. Reserved equals commitment and discounts. Number 3, the trap. Data in is free. Data out costs money. And finally, number 4, your tools. Cost Explorer helps you see the bill. AWS Budgets helps you control it. Bam! That's the core of it.
And that's it. See? Not so scary. You are now totally ready to tackle any pricing question they throw at you. So, let me ask you this. Based on everything we just went over, if you just opened a brand new AWS account today, what's the very first tool you'd set up to make sure your costs don't get out of control? Think about that. Now go get that certification. You've got this.
All right, let's talk about something that's going to get you some easy, guaranteed points on your AWS Cloud Practitioner exam. We're going to crack the code on AWS support plans, so you can walk into that test feeling way more confident.
So, first things first, we got to ask the most important question. How does AWS actually try to trick you with these support plan questions? Because, passing isn't just about knowing the facts. It's about seeing the curveballs they're going to throw at you. And with support plans, they have a favorite trick. But before we get to the tricky stuff, we have to lay a super solid foundation. So let's just simplify this whole thing down to its absolute core so it's impossible to get wrong.
Look, at its heart, this is incredibly simple. The more money you give AWS, the faster and better the help you get. That's it. More cash equals more personal, quicker support. It's really that straightforward.
Now, here's the official, kind of fancy way of saying it. AWS support is your lifeline. It's the service that gives you technical assistance and guidance. Basically, it's who you call when something's broken or you need an expert to help you out.
Okay, but just knowing a definition is, let's be honest, kind of boring, and it's not going to stick in your brain during the exam. What you need is a real-world analogy, something you already get completely. That's it. Just think of it like a cell phone plan. Everyone understands this, right? You pay for a certain plan, you get a certain level of service. AWS support is exactly the same concept. This analogy is going to be your secret weapon. And look how perfectly this fits. The basic plan, that's like having no data and just using free Wi-Fi at a coffee shop. You're on your own, searching through community forums. Step up to the developer plan, and now you can actually email a real person. Nice! Move up to business, and you get to call someone on the phone 24/7. And at the very top, the enterprise plan, you get your own dedicated manager, a person who knows your name and your account. See the pattern? It just gets faster and more direct with each level.
Okay, analogy is locked in. Now let's get tactical. We're going straight to the source, the official exam guide, because why guess what's on the test when they literally tell you? And boom, here it is. This is pure gold. The exam guide says this domain is 12% of your total score. 12%. That is a massive chunk of points. So getting these support plan questions right isn't just a nice to have, it's absolutely crucial if you want to pass.
And here's the best part. You do not need to memorize every single feature of every plan. So many people waste time doing that. You only need to focus on what the exam guide explicitly says is on the test.
And here they are. This list right here is your study guide. It's the answer key, straight from AWS. Basic, developer, business, enterprise on-ramp, and enterprise support. Burn these 5 names into your memory. Nothing else matters for the exam.
But then, the guide also mentions these other things, like white papers, the Knowledge Center, blogs, documentation. And this right here, my friend, is where they build the trap. They mix these free, self-service things right in with the paid support plans.
Which brings us right to that common exam trap we talked about.
Once you see it, you'll be able to spot it from a mile away and you will not fall for it.
The exam really just boils down to this one simple question. Can you tell the difference between something that gives you access to a real, live human for technical help and something that's just for reading by yourself?
So you need to draw a hard line in your mind. On one side, you have the paid plans, developer, business, enterprise. This is how you get help from a person. It's interactive. On the other side, you have all the free stuff, white papers, blogs, docs. This is where you find answers yourself. It's self-service. So if an exam question asks how to get technical assistance from an AWS expert, the answer is always going to be one of the paid plans, never a blog post.
All right, let's lock all this in. Time for a super fast 30-second recap of exactly what you need to remember when you're sitting in that exam room.
Number 1. Memorize those 5 support options from the guide. Basic, Developer, Business, and the 2 Enterprise tiers. Got it? Good. Number 2. Know the core difference. You pay for a plan to get interactive help from a person. Number 3. All that other stuff, the white papers, blogs, and docs, that's just for self-service reading. That's the whole game right there.
And that is it. That's how you simplify AWS support plans to absolutely nail those exam questions. You focus on what the guide says, you understand that core difference, and you've just turned a confusing topic into easy points. So now you got to ask yourself, what other parts of the exam can be broken down just like this?